This is for year 12 of the maths. We're going to look at exercise 2H, question 4. Okay, so this is to do with standard scores on the normal bell curve. So in a normal distribution, um, we say that the mean value is 0, and one standard deviation as a z-score will be +1, two standard deviation +2, three standard deviation +3. And you can go backwards as well. So if I go one standard deviation to the left, that's -1, -2, -3. Okay, so we've got the weights of a large group of 14-year-old girls that have a mean of 54 and standard deviation at 10 kilograms. Kate's weight is 56 kilograms. Determine her standardized weight. Okay, so standardized is the same as z-score. A lot of students are confused about what standardized score is. It's the same as the z-score. So where does Kate lie in this continuum? Okay, is she the mean or she's somewhere else? So how do you determine it? You use the formula. So the formula is z-score or standard score equals the actual minus mean divided by the standard deviation. Okay, so actual for Kate would be 56 kilograms minus the mean, which is 54 kilograms, and you're dividing by standard deviation 10 kilograms. So 54, okay, so you do it on calculator. I'm just going to have to do it by hand because I don't have my calculator here. That's 210, that's point 0.2, okay? So 0.2, so her Z scores 0.2. So what does that actually mean? She's just slightly around here. So Kate's weight is slightly around here. So she's pretty normal, okay? She's pretty normal. She's not one standard deviation away, more than one standard deviation away on either side. B, we have a standardized weight of -0.75 to determine the actual weight. So actual, the formula, so you should copy these formulas in your book. Actual equals, I think it was the mean times the z-score. Mean, oops, go back. So mean plus z times standard deviation. Okay, so the mean is 54. The z-score is -0.75. Now, you got to be careful with negatives. I always like to put brackets around the negative value, just in case I make a mistake, and then times by standard deviation of 10. Okay, so that's 54 minus 7.5. So that's 47, so 46.5 kilograms. Okay, which makes sense. Okay, because we know if I were to map out actual scores, if I were to map out actual scores, then um, this value, the mean value, would be 56, and this will be 66, 76, 86, 46, 36, 26. A z-score of -1 or -0.75 will be somewhere around here, and it's around 46.5, which makes sense because it's between 46 and 56. Okay, that makes sense. C, hang on. Assuming the girls' weights approximately normal distributed with a mean of 50 and a standard deviation 10, determine the percentage girls who weigh more than 74 kilograms. Okay, so weigh more than 74 kilograms. So what that's saying is, it's a different question. Um, we've got a mean of 54 and a standard deviation 10. Okay, so this is a different part of the question. So for part C, we've got 54, 64, 74, 84, 44, 34, 24. Okay, more than 74 kilograms is this region. Okay, and if you go back to so it's where, how many standard deviations from the mean? 1, 2, and we're more than 2 standard deviations. So we'll go back to the previous question. So if we go back to the previous slide, more than 2 would be here. Okay, so it would be 2.5%. So C would be 2.5%, because there's that area there. Between 54 and 64, 54 and 64 is here. If you go back to the previous slide, 54 and 64 is here, so that's 34%. So D, 34%. Girls with standardized weight less than -1. Okay, so this is a bit tricky because it's telling you in standardized weight. So in terms of standard deviations, less than -1 would be here. Oops, let's go back. Would be here. Okay, so that's one standard deviation to the left, and we want more than one standard deviation to the left. So let's go back to the bell curve. More than one standard deviation to the left would be here, so that would be 16%. 16%. And finally, F, the percentage of girls with greater than -2. Greater than -2 means, if I can get a different color, the pen, doesn't work. More than -2 means like here. Okay, so if to add all these together. Well, I know this is 50%, so this is 50%. I need to add 34% to that, so that's 84%. 84% plus 13.5. Okay, so that should be, we'll do my maths. So F, we've got 50 plus 34 plus 13.5. Okay, so that's 80, 84, 97.5%. So that's these questions. So it's really important that you understand the difference between actual scores and putting those in normal distribution. So right here, and knowing what the z-scores actually mean. So z-scores tell you the same information, but with z-scores you either got zeros, ones, and twos and threes, and -1s, -2s, and -3s. Whereas actual scores are dependent on, what your mean is and what your standard deviation is. So hopefully that helps.